All right, so let's review the classwork that you guys had on systems of inequalities. So we have a situation about Cole. He inherited a 600 square meter lot near Lowe's Motor Speedway, wherever that is. He plans to make money parking trucks and RVs during big races. A truck requires 6 square meters of space, and an RV requires 30 square meters of space. Cole thinks that he can handle no more than 60 vehicles. So let's start with actually writing our system. So the first system actually is right here. Okay. He has 600 square meters. So that means that whatever amount of space we use, we can't exceed it, or it has to be less than or equal to 600. Okay. We don't have to use up all the space, but we definitely can't use up more than what we have. Let's get more into that. He says that the trucks take up 6 and the RVs take 30. So what we can do is, I know on your paper it says to use R and T, but since we're going to be graphing, it will probably be easier to use X and Y. So how about we make trucks the X and make RVs the Y? Okay. And we know how much each one is worth. So for our first system, we know that we have 6 square meters per truck, and we're going to add 30 square meters per RV, and this cannot exceed, which means it has to be less than or equal to 600. So that's our first one. The second one is easier. It just says he can handle no more than 60 vehicles. So that means that if I put together my trucks with my RVs, I cannot exceed 60. Okay, so there we have our systems. Now for the next thing we're going to graph, when you simplify this, which you should be able to do this on your own, for the first one you should get that y is less than or equal to negative 1/5 x plus 20. For the second one, that one was really easy. You just subtract x on both sides, and you get y is less than or equal to negative x plus 60. Okay. So when we graph it, it's important that you choose your units wisely. You don't want to go by ones because our numbers are kind of big. So I am going to 1, 2, 3, 4, 5, 6. I'm going to go by tens. 10, 20, 30, 40, 50, 60. And again, you can use your calculator to give you a kind of roughly give it to you, but let me rewrite what the equation was, or what the inequality was, excuse me. Okay, so when I graph it, I go to my y-intercept. I'm doing the first one first. So my y-intercept is 60, and the slope is negative 1. So let me go ahead and label 3, 4, 5, 6. So my graph would look somewhat like this. Okay. So if you look at it, my y is less than, so I'm going to be shading underneath this line. And it is solid because it's or equal to. Now I'm going to graph the second one. My y-intercept is it's positive 20, so I'm going to go to 20 on my y-intercept, and my slope is negative 1 over 5. So that means so when you graph the second one, it should look like this, the lower one. And again, since the y is less than, we're also going to shade underneath. But this time I'm going to use a different color so that we can see it a little bit better. Whoops. So when I shade under this line, I'm right here. Okay, so what you want to do is you want to see where the overlap is going to be. And where that overlap happens, I'm going to color that in a different color because that's where it actually matters. I'm going to color that in blue. The overlap is pretty much everything that comes underneath the last line that we came up with. Okay, what satisfies both of our systems. So this is what our graph would look like. Okay, this is a neater version of the graph because the computer made it and I didn't, and the computer's better than me. So this is just, but it did do it without the line. So I'll show you what the lines should look like for the inequality. Roughly, this is what the first line was looking like, and the second line was down here. So where you see the red and the blue down here, this shows you where your system is. So what you can do is you can look at your coordinates pretty much. This is your x and this is your y, and you can see if the coordinates fall in between where they have the overlap. So if you go to 32 on your x-axis and then go up to 28, you'll see that that's around here. You'll see that that's around here, which is not in your overlap. So as far as your explanation goes for the first one right here, you would say no because it doesn't satisfy the second inequality. Okay, and the second inequality says that you can't take up more than 600, 600 square feet. So for the next one, if you go to 22 on your x and then go up to 14, it does fall where you want it. Okay, so it's around there. It's not perfect, but it's around there. So this one actually works, the second one. Okay, keep in mind, it does not have to be exactly equal to 600 square feet or exactly 60 cars, but it has to fit the inequality. Okay, for the last one, you can already see that 58 plus 8 is greater than 60. Okay, we can't surpass that. So without even using the graph, you can see that that one wouldn't work because that's too many vehicles. All right, for the last one, it asks, what is the real world meaning of the shaded region? So if we go back, the shaded region represents the different combinations of trucks and RVs that you can have. And I wrote that as my answer right here. Okay. Now for E, on my graph, I just showed you, for space purposes, I just showed you the first quadrant. But technically, if you saw the whole graph, which you may have saw in your calculator, you can't really count all of the solution as a solution for this particular context because you cannot have negative RVs or negative trucks. So you're really only looking at your first quadrant.